Mga kahugot, alam natin na ang electrons ay matatagpuan sa paligid ng nucleus. Pero here's the question. Saan exactly pumupunta ang mga electrons? Hindi sila basta-basta nagsisiksikan kung saan may space. May sinusunod silang arrangement, and this arrangement is called electron configuration.
Welcome to my channel, Science with a Touch of Hugot. Let's explore! Discover short stories and discover ourselves.
So today, let's learn how to write the electron configuration of an atom. 1. What is electron configuration? Electron configuration is the arrangement of electrons in the energy, levels, and orbitals of an atom. Think of an atom like a building. The nucleus is at the center, while the electrons occupy different levels and rooms around it. These energy levels are represented by the principal quantum numbers 1, 2, 3, 4, and so on. But here's the important part. Each energy level is divided into smaller regions called sublevels. 2. The 4 sublevels. There are 4 main types of sublevels: S, P, D, and F. Each sublevel contains a certain number of orbitals. The S sublevel has 1 orbital, the P sublevel has 3 orbitals, the D sublevel has 5 orbitals, and the F sublevel has 7 orbitals. Remember, each orbital can hold a maximum of 2 electrons. So, S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. 3. The order of filling. Now comes the tricky part. Electrons don't simply fill energy levels from 1 to 2 to 3 to 4. They fill the available orbitals according to their energy. The usual filling order is 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, then 5s, then 4d, then 5p, then 6s, then 4f, then 5d, then 6p, then 7s, then 5f, then 6d, and finally 7p. That's why we use the familiar diagonal rule to help us remember the order. 4. Let's try hydrogen. Let's start with the simplest element, hydrogen. Hydrogen has an atomic number of 1. That means a neutral hydrogen atom has 1 electron. So where does that electron go? It enters the lowest energy orbital, 1s. Since there is only 1 electron, hydrogen's electron configuration is 1s1. The superscript 1 tells us that there is 1 electron in the 1s orbital. 5. Helium. Helium has 2 electrons. Both electrons can occupy the 1s orbital because an orbital can hold a maximum of 2 electrons. So helium is 1s2. And now, the first orbital is completely filled. 6. Let's try oxygen. Now let's make it more interesting. Oxygen has an atomic number of 8. So a neutral oxygen atom has 8 electrons. We fill them following the order. First, 1s squared. That's 2 electrons. Next, 2s squared. That's another 2. We now have 4 electrons. We still need 4 more. So we move to 2p4. Therefore, the electron configuration of oxygen is 1s squared, 2s squared, 2p4. Let's check. 2 plus 2 plus 4 equals 8 electrons. Perfect! 7. Hund's rule. When electrons enter orbitals of the same energy, such as the 3p orbitals, they tend to occupy separate orbitals before pairing up. This is known as Hund's rule. For oxygen's 2p4 electrons, the arrangement is like this. Notice that the electrons occupy the 3 orbitals individually before 1 electron pairs up. Parang sa classroom, may bakanteng upuan pa. Bakit ka makikipagsiksikan? That's the idea behind Hund's rule. 8. Pauli Exclusion Principle. It tells us that an orbital can contain a maximum of 2 electrons, and those electrons must have opposite spins. That's why we represent a pair as up and down, not up and up. So remember, 1 orbital equals maximum of 2 electrons. 9. Aufbau Principle. The word Aufbau comes from German and means building up. Electrons occupy the lowest energy orbitals available first before moving to higher energy orbitals. So when writing electron configuration, we follow the energy filling order. 10. A quick example, sodium. Sodium has an atomic number of 11. So a neutral sodium atom has 11 electrons. Following the filling order, 1s2 equals 2 electrons. 2s2 equals 2 more electrons. 2p6 equals 6 more. And finally, 3s1 equals 1 electron. Therefore, sodium equals 1s2, 2s2, 2p6, 3s1. Let's add them. 2 plus 2 plus 6 plus 1 equals 11 electrons. 11. The noble gas shortcut. Writing the complete electron configuration can become long for larger atoms. That's where noble gas notation can help. For sodium, the configuration 1s2, 2s2, 2p6, 3s1 can be shortened. The first part, 1s2, 2s2, 2p6, is the electron configuration of neon. So we replace that part with the symbol for neon in brackets. Ne 3s1. Much shorter. 12. 3 rules to remember. So remember these 3 important principles. Number 1. Aufbau Principle. Electrons fill lower energy orbitals first. Number 2. Pauli Exclusion Principle. Each orbital can hold a maximum of 2 electrons with opposite spins. Number 3. Hund's rule. Electrons occupy equal energy orbitals singly before pairing. Ma'am, hugot moment. Parang sa buhay lang mga kahugot. Hindi porke may space, ibig sabihin doon ka agad dapat pumunta. May tamang order, may tamang lugar. At minsan, kailangan mong maghintay bago ka makahanap ng tamang spot. Just like electrons, everything has its proper place. Recap. Electron configuration describes how electrons are arranged in an atom. The 4 major sublevels are S, P, D, and F. Their maximum capacities are S equals 2. P has a maximum of 6. D has a maximum of 10. F has a maximum of 14. And electrons fill orbitals according to their energy, following the Aufbau Principle, while also obeying Pauli's Exclusion Principle and Hund's rule. And that's how we write electron configurations. If you finally understand where those superscript numbers come from, congratulations! You're one step closer to mastering the language of the atom. Remember, even electrons have a proper place. So if you're still searching for yours, keep filling your configuration one step at a time. This is Ma'am Hugot, making science easier to understand and a little more relatable.
Thank you for learning with me today. Remember, biggest classroom. Don't forget to subscribe for more lessons. Keep finding the Hugot in every day. See you in the next lesson.